traction specific fuel consumption system. This is traction specific fuel consumption system designed, developed and manufactured by Neometrix Engineering Private Limited, Noida. This is traction specific fuel consumption system designed, developed and manufactured by Neometrix Engineering Private Limited, Noida. This equipment measures, monitors the diesel consumption of a locomotive engine. This validates and confirms the diesel locomotive engine fuel consumption pattern. This system works on weight measurement, and as the weight of the fuel in the tank gets consumed by the locomotive engine, the weight of the fuel in the tank goes down, and that is how the consumption is measured. So this system is developed for GE, General Electric, for their locomotive engines for Indian Railways, and this is how it is. This system is made up of three major subcomponents. The first major equipment is this fuel skid called fuel skid. In this, the fuel tank is kept. The second system is the chiller system. The chiller system, which is used to control the temperature of the diesel during this measurement. As it is a traction fuel consumption measurement system, it has to be measured at a given temperature. That is how the standards have been set. So this chiller, 12-ton chiller, is used to control the temperature of the fuel which is being sent into diesel locomotives. And the third system is the PLC-based control system, which is sitting here. And this is all explosion proof. This system is the tank weight measurement system. This system measures the tank weight. As the fuel is being consumed, the tank weight is going down, and that is how the consumption of diesel in the locomotive is being monitored. I will reiterate, this is explosion proof. This is from Mettler, Toledo in USA. The load cells are there which are kept below the tank, and those load cells are being measured, and the measurement is being shown on this load cell measurement panel. So this is showing the tank weight, and next to it is our PLC controller box. This is the brain behind the complete system. From here we are able to control the chiller, we are able to control the filling pump, and we are able to control and monitor various other parameters. Now I will take you to each and every part of this equipment one by one. So just to reiterate, the system is traction fuel consumption measurement for locomotive engines. So the engine which will be manufactured by General Electric for Indian Railways, that engine will come and its fuel consumption efficiency will be monitored by this system which is developed by Neometrix Engineering Private Limited, Noida. This is designed, developed, manufactured by Neometrix. Now I will take you to various ports that are there in this system. These are the ports which are connecting to the locomotive. I will take you one by one to various ports. This is fuel from loco tank. So the line of diesel from loco tank is connected here, and there is a pump installed here, pump and motor, which is explosion proof. And this pump and motor takes the fuel diesel from the locomotive tank, and it fills the tank, which is stainless steel 304, which is kept inside this cover. Please note that this is not the fuel tank. This is just the cover of the fuel tank. The fuel tank is sitting inside it. The fuel tank is stainless steel 304. As I will remove this cover, you can see the fuel tank. This is the fuel tank. This fuel tank is made up of SS304, and this fuel tank is kept on 4 load cells. I will show you the load cells which are sitting at the bottom of the tank. I will remove this cover. And you can see the load cells sitting inside the fuel tank cover. This is the Mettler Toledo load cell. There are 4 load cells kept below the fuel tank. This is the stainless steel fuel tank, and this is kept on 4 load cells. This is freely standing on 4 load cells which are measuring the weight of the tank all the time. So as the diesel in the tank gets consumed, the weight of the tank goes down, and that is monitored by our fuel measurement system, tank weight measurement system, and that is how the consumption is monitored and recorded. I will show you another load cells which is sitting inside this. Let me remove the cover. Please come to the other side. Let me see. There are 4 load cells and there are 4 covers. So this is another cover, and this is the 4th cover. So there are 4 load cells which are sitting below the tank. Now I will explain various other parameters of this system. We were talking about the load cells. Now there are 4 load cells. All those 4 load cell wires come to this junction box provided by Mettler Toledo USA, and all the load cells are terminated here, and from this junction box the cable goes to the Mettler Toledo explosion proof tank weighing digital panel, and this is TWS L series tank weighing system L series panel, which is monitoring the load being measured by the 4 load cells, and it is communicating to this PLC controller on RS channel in digital manner. Now I will explain how various pipes are being connected. So I just talked about this port, fuel coming from loco, and that fuel is pumped using this motor and the pump. This motor and the pump is being used to fill the SS tank of the fuel. I will explain the piping. Now this pipe is coming from the loco. There is a valve here which is actuated valve. This valve is normally it is closed, and when I have to transfer the fuel from the loco to my SS tank, I will open it from my controller. From here the fuel will go into the pump suction, and as the motor runs, this pump will pump it out. This is the outlet of the pump, and this goes into a filter. This filter has an electrical clogging indicator also. So in case this filter gets choked, this will show on our electrical panel. After filtration, this fuel is coming out, and we are having another valve again. This is electrically actuated. Explosion proof valve. So this pumped fuel is coming through this, and as you see, this line is coming, and this line is going into the tank, and my colleague will show this label. It says fuel from loco tank. So the fuel from loco tank is pumped through our own electric motor and pump through those valves and the filter, it is getting filled into the tank. Now this tank has got level switch, which is again explosion proof. Because of diesel, the electronics is explosion proof. This level switch tells us when the fuel in the tank is completely filled. Then automatically the pump will stop and the valves will stop, and that is how this tank is filled with the diesel. Now how the other operations happen? In the locomotive tank, there are various lines which are going from our skid to the locomotive, and there are various lines which are coming from the locomotive to our system. Like, I will explain one by one. This is coming into the tank. This is regulated power return, and this is coming from loco to the tank. This one is loco suction. So from the tank, the diesel is going to the loco suction. Then you see these lines. This is coming from the loco. This is coming from the loco. This is right bank leak off. This is coming from the loco. This is left bank leak off. This is coming from the loco. This is fuel transfer pump relief. This is coming from the tank. Right now we have kept it spare, but it will be used for gravity return. And this line is regulated power return from the tank. And this one is going to the tank, and this is the loco suction. Now various lines are going to the loco, and various lines are coming from the loco. In between, we have to make sure that the diesel temperature is maintained at the required level. For that, we have provided heat exchangers. These are shell and tube heat exchangers. There are two shell and tube heat exchangers, one here and one sitting above it. These two heat exchangers are used for cooling the diesel which is going into the loco or which is coming from the loco into this tank. So there is this big one and there is this small one. The big one is used for cooling the diesel fuel which is going into the tank, which is going into the loco suction. This is the loco suction, and this is going through this big heat exchanger. So this big heat exchanger is cooling the diesel which is going to the loco suction. So this heat exchanger is taking the diesel from the loco suction. This is the loco suction coming from our fuel tank, and it is going into our big heat exchanger here, and this is being cooled in this big heat exchanger, and after cooling it is going to the loco through this loco suction. And the rate of cooling, the temperature of cooling is maintained by this automatic flow control valve. This is temperature control valve. This automatic valve maintains the temperature to the loco suction, and the feedback of that temperature is taken by this RTD sitting here. This is a temperature transmitter. This temperature transmitter gives the feedback to our PLC, and accordingly this PLC gives control signal to our controller here, which controls, this controller controls the chilled water supply into the heat exchanger, and that is how the temperature of fuel here is being controlled. The chilled water supply into our system is coming from a 12 ton chiller system. This is a 12-ton chiller which is having its own PLC control panel, and this panel is used to locally control. Otherwise, this chiller is totally controlled by the PLC which is sitting inside our fuel skid that we saw there. So this chiller is operated from the PLC, and it provides the chilled water through these lines, cold chilled water through these lines, to our heat exchangers, which cools the fuel which is going into the loco suction, as I just explained. Now there is another heat exchanger, the small heat exchanger, and this small heat exchanger is cooling the fuel which is coming from the loco. This fuel is coming, this diesel is coming, regulated power return. Regulated power return is coming to our tank finally. So this is hot, we need to cool it, and to cool it we pass it through this heat exchanger. So this fuel comes through this line and this goes into this heat exchanger, and out of this heat exchanger it starts from here, and this is regulated power return going into the tank. So this is cooled before taking the fuel from the loco into the tank, because that is hot. It will not allow us to maintain the temperature in the fuel tank. That is why the heat exchanger is provided. So there are two heat exchangers. This small one is for taking the fuel, regulated power return, which is at high temperature, and then cooling it and then sending it to the tank which we have provided, the stainless steel tank. And the big heat exchanger is to take the loco suction oil, diesel oil from our tank, cool it and then give it to the loco suction. So, and like this controller is controlling the temperature in the big heat exchanger, this controller is controlling the temperature of the small heat exchanger. So this controller controls the water flow, chilled water flow rate in such a way that temperature here is maintained at desired level. So this fuel traction specific fuel consumption measurement system that you see, this is traction specific fuel consumption measurement system for the loco engines, for 6000 HP loco engines, for 5000 HP loco engines. This system is used, and as I explained, the tank is kept inside this heavy metallic cover so that it is isolated from wind outside or from the vibrations outside. The tank is kept on the 4 load cells, which in turn are kept on anti-vibration pads, and that tank is put on a foundation which again is sitting on anti-vibration pads. So the tank weight weighing system is always measuring only the weight and nothing is influencing it. All these pipelines which are going inside, they are not touching the tank body in any manner. These are hanging from this tank top cover. So in the next video I will explain you, I will lift this tank cover and I will demonstrate how those lines are going inside and how they are not touching the SS tank. So this is a brief explanation of a system designed, developed by Neometrix Engineering, manufactured by Neometrix Engineering for General Electric, that is GE, which in turn will use it for measuring the locomotive diesel consumption for the engines that it is supplying to Indian Railways. It is for 6000 HP engines and for 5000 HP engines, and this system is fully automated and developed in accordance with international standards. Thank you very much.